Graphing simple rational functions. So we will graph the following, but I will just pick on maybe a couple of these, say number 66 and number 68. And it says to include in the graph the equations of the asymptotes and the dominant terms. Alright, if that will only occur if there is a dominant term. But for all these, it looks like we don't have any dominant term on the numerator, because all of these is either the numerator and the denominator have the same degree, or the denominator dominates the numerator, so the limit of the functions as x approaches infinity would be 0. So let's look at number 66. First of all, in number 66, we want to look at the limit of -3 over x minus 3 as x approaches plus or minus infinity. And this is a 1 over, it's a case of a reciprocal of a 1 over x type of expression, so the whole thing will approach 0. Now what does this imply? That means it's got a horizontal asymptote at y equal to 0. Now when we take the limit of -3 divided by x minus 3 as x approaches 3 from the right, and we also take the limit of -3 over x minus 3 as x approaches 3 coming from the left, then we will find out what is the vertical asymptote. So here you've got a negative numerator divided by something that's getting close to 0. So you have a negative divided by something that gets close to 0 positively, so the whole thing would be negative infinity. Now as we let x approach 3 coming from the left, so the difference between x and 3 would be approaching 0 in a negative sense. In other words, they're close to 0, but they are all negative. And then you have a negative sign, so the whole ratio would go to positive infinity. Now what does this imply? That means it will tell us how the graph will behave. So let's go ahead and let's just plot number 66 here, since it's very close to our problem. So we've got a vertical asymptote at x equal to 3. So 1, 2, 3. Draw the vertical asymptote. And then we also have a horizontal asymptote at y equal to 0. So it coincides with the horizontal axis right there. Okay, so the next thing is, how do I graph the function? Well, this is where you look at the end behavior, or rather the vertical asymptote, and see how the function behaves close to the vertical asymptote. So it goes to negative infinity as you approach 3 coming from the right. So this graph is going to approach this way. Okay, and then when you approach 3 from the left side, okay, so you're approaching 3 from the left side, the value of y's approach plus infinity. So it goes that way. Okay, and then what is the end behavior as x approaches plus or minus infinity? It approaches the horizontal asymptote. Okay, so this will now approach the horizontal asymptote. So this is the behavior of the graph for number 66. And one thing that could be helpful is that you can plot points close to 3, or even where x is equal to 0, you know, around the area where you have the vertical asymptote. That way it will guide you in how you will graph the function. And of course, use the fact that you have a horizontal asymptote at y equal to 0. Okay, and then of course that vertical asymptote tells you where it will go. Alright, how about number 68? let's do number 68. So in number 68, we see that the horizontal asymptote is, okay, when we take the limit of this function of y as x approaches plus or minus infinity, we see that the horizontal asymptote is when y is equal to 2. So let's go ahead and plot the horizontal asymptote. So remember, the horizontal asymptote is the behavior of the function, the limit of the function as x approaches plus or minus infinity. Then the next thing we do is what makes the denominator 0. And in this case, you can't cancel out what makes the denominator 0. So we mark, say, -1 right here, because that will make the denominator 0. So already we know that the function approaches y equal to 2 as x approaches plus infinity and minus infinity. But where do we plot it? Well, look, first of all, we can plot a few points here. Let's say when x is 0, y is 0. When x is 1, 2 times 1 divided by 1 plus 1 gives us 2 over 2, so that's 1. So those are helpful points that we can include. Okay, now the next thing we have to look at is what happens when we take the function approaching -1 from the right. So when x approaches -1 from the right, okay, this whole thing approaches 0 positively. However, this will be 2 times something close to -1. We'll make it negative divided by a 0 that's positive in the positive sense. So negative divided by a positive 0, if you want to call it that way, will approach minus infinity. So you see that this graph, as x approach -1 coming from the right, will approach minus infinity. And then when we look at, when we take the limit of y as x approaches -1 coming from the left, the denominator will approach 0 in a negative sense. And then here, this is still negative. So negative divided by a -0, you'll get positive infinity. So you see how the graph approaches plus infinity. And then we know from the horizontal asymptote that this will approach y equal to 2 both ways. So there we have created the graph for number 68. With the help of evaluating limits as x approaches the 0 of the denominator from the right and from the left, and then the horizontal asymptote aids us in finding the horizontal asymptote when we take the limit as x approaches plus infinity or minus infinity. Inventing graphs and functions. Okay, in exercises 69 through 75, what you want to do here is really just to look at every condition that is specified in each problem and just draw a graph that will satisfy these. And that's why they are not, your answers will not be unique, because there are different ways of graphing every problem here. So what I'm going to do is just work on my own example or my own problem. Okay, what are the conditions that are given? F of 0, 0 means that when x is 0, y is 0. We have to that when x is 2, y is equal to 4. So there you go. When x is -2, right, y is also 4. So far, that's what we have going when we satisfy these three conditions. Now there are other added conditions. It says that when we let x approach -infinity, your y values approach 6. So let's say 6. So let's create a horizontal line on the left half of the plane, and then it says that the limit as x approaches infinity, the limit of y is equal to 0. So in other words, it tapers off at the horizontal axis. So let me just write it out here. So what happens is that it approaches 6 this way, and it approaches y. So there are different ways you can graph. This can go on like that, or it can go straight here. It can even head out, and then eventually it will taper off at y equal to 0. As you can see, there are just different ways of graphing this. I mean, I could create another problem in the sense that it could behave this way as well. So suppose we created a different curve satisfying the same conditions. So let's say then it could go eventually die down to y equal to 0. Then here this could either go up and then die down to y equal to 6. So you see that your graph will not be unique whenever you have these types of problems. I mean, I could really create as infinitely many functions as I can.